Hi everyone, welcome to my YouTube channel Tech Data Engineer. So today we will discuss the DSA roadmap for data engineer. So this topic is basically for data profile, the persons who are applying for data scientist, data engineer or any data analyst role. This is not a specific for any development role because for development profile we have to cover few more topics which is basically required for DSA round, but this video mostly covers the topics which is asked in DSA round for data engineer or any data profile, like either it's data scientist, PI profile, data analyst profile or data engineer profile. Okay, so before starting, first we need to understand what are the prerequisite to start the data structure. What are the things we need to understand before writing any optimal solutions. Okay, so the prerequisite for any DSC course is like you have to be proficient in one of the programming language. So you have to choose one of the programming language in which you are proficient. So for data profile or any other profile, either you have to choose Python, Java, C++ or Scala. So if you are from data background, we'll recommend to go with the Python, because you can do other stuffs also with the help of Python, and that is also required to do, I can say, some analysis, data analysis or ETL related things based on Python, or you can do this codings also in Python. If you are from different profile apart from data profile, you can choose Java, C++, and Ruby also is there, you can choose that. So this is the prerequisite, one of the programming language in which you are proficient, so that you can write your code in that. Okay, then coming to next, you need to understand the time and space complexity. So time and space complexity basically deals with, okay, if you are solving a problem, so how much time it will take. It will take order of n time or order of n square time, log n time, constant time or polynomial time, exponential. So how much time your, you can say, so in executions, how much time it will take to do the uh, to solve the problem. Basically it is your time notations. Okay, so for that you need to understand the your asymptotic notations. Okay, so asymptotic notations is of three types: big O, big omega and big theta. So you can say that it's like a worst case, best case and average case scenario also. Okay, so this so in mathematical terms, so notation terms, we are we are writing like a big O, big omega for average case, big theta for best cases. Okay, and what are their common runtimes? So you can solve the any problem, or your problem will take constant time, logarithm time, or in linear time or polynomial time, exponential time or factorial time. So these are the time which basically you can notate like it's a big O of n. It means that you need to suppose there is an array of n element, you need to scan linearly, then you have to go one by one. So how much time it will take? It will take big of n time. Okay, if there is a sorting array, if you want to search the first element, then it will take constant time big of 1, because always the first small element, if you wanted to search, then it will be the first element, so it's constant of 1 time. So similar way you can just do that. So this all these things we will discuss later. So this is just a general topic, so general video where we are just discussing the detailed about the what are the topic we need to cover for DSA for a data engineer. Okay, so after asymptotic notations, come to the DSA part. So in data structure we need to cover the topic array, then stack, queue, linked list. These are the linear, and then a string. So in that, these are the most asked from array, stack, queue, linked list and string. They are the most asked questions from this. Then apart from that, bit intermediate level, and questions asked from tree. So tree you need to cover binary tree, B tree, binary search tree, AVL tree, and then traversal also you need to cover, because sometimes they ask the question on traversal. What are the in order, pre-order, post-order, traversal? They are asked sometimes the ordering of this traversal. Okay, so you need to cover these things also in order, pre-order and post-order. Okay, so after covering that, in graph we have to cover the graph reversal like breadth first search, depth first search, so that we need to cover. Okay, so in tree we there are other topics also, but that is not required, like b plus tree, skip list, isam, and 2 to 3 tree. So these are the these are the things which is not mostly required for data profile. So only b binary tree, b tree, binary search tree, evil tree, and their ordered reversal, these are the important things. In graph you cover the bfs and dfs, like breadth first search, depth first search. Okay, then coming to that heap part. So in heap part you need to cover mean heap, max heap. So mean heap, max heap, that is required, so you need to cover that also. Okay, coming to algorithm. So algorithm, like they are asking question related to searching, not linear search, mostly on binary search they are asking questions. Then sorting. So sortings, this is also basic level of DSA they are asking. So they'll ask question on bubble sort or insertion sort, selection sort. After just tweaking something, they will ask question related to merge sort, quick sort, heap sort. So these are the basic sortings which is basically required. Apart from that, there is a hashing. Then after searching, sorting, and hashing, there are some problem solving technique like brute force, backtracking, greedy, recursions, two point techniques, dynamic programming, sliding window techniques. But that is so whatever I have mentioned here, that is sufficient for you can say data profile. It's a greedy algorithm, divide and conquer, recursive, and dynamic programming. So in that also, divide and conquer and recursive hashing, that is most important. So questions related to dynamic programming, the company who are from advisories or from stock, this company like DP World and all, they're asking questions from dynamic programming mostly, or some big companies they are asking question, mostly question related to dynamic programming. But for data profile they are not asking on to that like very high level of questions, that is basic to intermediate. Okay, so and then in problem solving we can we have some other techniques also, like backtracking, brute force, sliding window techniques, but these are two pointers techniques. But that is not mostly asked for data profile. Okay, so only this whatever I have mentioned: searching, sorting, hashing, greedy, dynamic, recursive, and this dynamic programming, these are sufficient to crack that. Okay, then coming to some graph reversal, like graph data structure. Apart from BFS, DFS, if you have time, apart from BFS, DFS, if you have time, you cover that Dicastra algorithm, then Bellman-Ford algorithm. These are the shortest path algorithm. You can cover these topics, or at least the basic idea, like what is Dicastra algorithm, why Bellman-Ford, what are the time complexity, why we are using, for what type of problem we are using that algorithm. Then minimum spanning tree, like Prim's algorithm, Kruskal algorithm. So if you'll cover the basic level of this also, that is fine. Okay, because sometimes questions asked related to that also. Okay, so these are the topic basically we will cover for like DSA for data engineer. Okay, thank you, thanks for watching.